can tell there's a special feeling in the audience tonight, and that can mean only one thing. It's time to bring on a great entertainer, a great humanitarian, and my personal friend for over 157 years. Ladies and gentlemen, Bill Nye, the Science Guy. Bill, nice to see you. They love you, Bill. Bill, I see all sorts of exciting things, water, glasses, electronic apparatus. Looks really exciting. What are we going to do tonight?
Well, John, we're going to talk about pressure. We're going to talk about pressure, specifically atmospheric pressure. John, nothing particularly dangerous eye-wise tonight, but you know, it's a great tradition.
What a shame.
It's a great tradition, and so I want you to don the safety glasses.
Safety goggles. Great.
And tonight I chose the red. I think this could be my favorite shirt.
Oh, thank you.
The whole year. I'm not saying. Very cool. John, you look very sharp. Now let's get started right away. Nothing too spectacular. Ordinary deck of cards. I've happened to have selected the Joker. This is a what, John?
It's
Griffin low form.
Test tube.
This is a test tube, right. Now,
Okay.
you may do this in a restaurant with a drinking glass, but in Nye Laboratories, we do it, of course, with the test tube. Everyone's familiar with the traditional experiment. Okay, right? Right? You're with me? No applause? That's fine.
That's okay, yeah. You know, that's right. Only
Okay.
applaud if you feel like it. We're not...
Esther Williams Joker there. So, okay.
That's
Now,
great.
John, that's fine. Now, what held the card up?
A little bit of adhesive that you secretly put on the end of the
John,
tube.
no, John. It was atmospheric pressure, John.
That's right. That's what I meant to say.
Pushing up all around. Now, what causes atmospheric pressure, John?
The atmosphere.
Well, the atmosphere, but more specifically, gravity, John. Gravity's pulling down all the time on the air and creating pressure here at where is this?
Sea level.
Sea level, very close, John. We put a little water in the great cylinder of science.
Okay.
No need to add a joker, but you can. Then
Okay.
we got to swirl the water, John. You know, whenever we have a cylinder of science, we want to create a vapor in there, a little water vapor.
Swirling the cylinder of science.
Cylinder of science. Now, John,
Okay.
we're going to pressurize it as though we were atmospheric pressure. Then we're going to release the pressure as though we were a cloud at high altitude. See, as the air reaches high altitude and expands, it cools, and water vapor comes out of solution. Now, when it comes out of solution, it has to nucleate on dust particles, which we'll get from these matches, and see that little bit of smoke. Now, John, energizing the pump.
Bill, there is no smoke in there.
Just the tiniest bit.
But you put the matches out.
In the bottom.
Right.
In there, John, it's a tiny bit of smoke, creating dust. Dust pervading the cylinder of science.
Okay, well...
And then when we release the pressure on the cylinder of science.
Okay. Let's see.
You ready?
Yeah.
3, 2, 1.
Whoa!
See, you don't see any cloud you won't see a cloud until there are dust particles in here. Kind of a subtle, cool thing.
That's very cool, Bill.
So it cools it because of gravity, lower pressure, high altitude. Now, John,
Okay.
while we're talking about atmospheric pressure, coming out of this side of the pump is pressure.
Okay.
Pressure. This side is vacuum. Now, John, if we follow the hose
This side.
over here, you'll find the vacuum is plumbed, as we say, into the great acrylic plate of science.
Okay.
Now, these pins are for alignment, just to save precious time.
Okay.
Now, can you hear the pump kind of slow down a little bit?
No. Did it?
I think
Valve
so.
closed and everything?
Let's just check.
Yeah, it's sticking. So it must,
Yeah, the valve is closed, John. And indeed, for you gauge buffs, there is
it's
vacuum
closed. That's
development.
fine.
Now,
That's fine.
John, what we will do, we will raise the cylinder of science. This will be another
I don't
cylinder
know
of
about
science.
this.
Up there.
You're going to get up there and do that?
No, John, I was thinking maybe you'd do it.
Oh.
John,
Okay.
yeah. Can we get a spotter in here?
Always willing to help the science guy. You know that.
Ed's wearing a
I'd do
science guy
anything.
shirt. That's very
whatever.
smart. The science team. Science
I
team.
don't know about this, Bill.
KSRX on the bottom. Now, the extra.
Okay.
Now, John, we're almost there. You see, atmospheric pressure is pushing down here, and so
I don't
great
know, Bill.
is the surface area of the acrylic plate of science.
Luckily,
that it will support your weight. Quite astounding.
We ready to do
Well,
it?
no, yes, we are. Very close, John. Yes.
Oh,
if you
boy.
will, please
You know, I couldn't
step
do that.
off the stool of science. Now, John, I know you're hanging there.
Okay.
I will open the valve. Everyone listen and let atmospheric
Bill,
pressure
turn
back
it
in.
off now, Bill.
Can you hear the
Bill,
pressure
turn
coming back
the
in?
thing off, Bill.
It's off, John. You're
Okay.
dangling. Don't face the audience. There you go.
Okay.
We're letting pressure back in to prove that the atmosphere is suspending and not those three.
Oh, I couldn't do this if I hadn't. Oh! That's great. Bill Nye the Science Guy.
PS 28.2 Weather. When cold and warm air masses meet, the weather can change, sometimes resulting in severe storms. Your essential questions for this section: why do differences in air pressure produce global winds? How do air masses interact along warm and cold fronts? What are the characteristics of severe storm systems? So the atmosphere exerts a force on all surfaces in contact with it. When air is heated, it weighs less and exerts less pressure than cooler air. Differences in air pressure set air in motion. So if you remember, we talked about hot air is less dense than cold air, and that's why it rises. The hot air balloon, the cup of soup, etc. Two factors produce these global patterns: unequal heating between the equator and poles and the rotation of Earth. Embedded in these wind systems, narrow bands of fast-moving, high-altitude air called jet streams. A low-pressure system, also known as a low, is a region in the troposphere where the air pressure is lower than the surrounding air. A high-pressure system, also known as a high, is a region in the temperature where the air pressure is higher than the surrounding air. A Coriolis effect is the direction of airflow that's affected by Earth's rotation. So the deflection of an object due to Earth's rotation is called just that.
Wind all over the world is caused by heating and cooling of the Earth. Wind can do work. Hey, look at that. And it makes sailboats go. Well, he went right through the door. Hey! Thanks, guys. Thanks. Whew.
Now, real wind doesn't come from a fan. No, in nature, wind is caused by the heat from the sun and the rotation of the Earth. That's what makes these intricate patterns of clouds that we see on this photo from space. It works something like this. This is our great big plastic wind box of science. These lights represent the sun. This ice represents the north and south poles. So here's what happens. Energy from the sun heats the land, and the land warms the air over the land. The air molecules get going faster, and they spread farther apart, so they don't weigh as much for the room they take up. So cold air can push the warm air up. That's why we say warm air rises. So look what's happening. The smoke shows us that the air is sinking over the cold poles, flowing over the cities, and then rising over the warm parts. See, it goes around in a great big circle. And that's what happens on the Earth. Now, there's one more thing. The Earth is spinning, so the wind starts spinning. That's why wind comes from all different directions. Wind is wild.
Air masses can be either polar or tropical, and even continental or maritime. There's 4 different types of air masses. So an air mass is a large volume of air with uniform moisture and temperature throughout. Air masses interact in zones called weather fronts. We have warm and cold fronts, and those create different types of weather conditions.
Animation is going to describe how precipitation happens at what are called cold fronts and warm fronts. These are weather systems that develop wherever masses of cold air collide with masses of warm air. And the name actually comes from war, where armies would meet along a battle line called a front. And one way to think about the difference between cold fronts and warm fronts is to think about which mass of air is going to win the battle. So we'll start with a cold front. This is a situation that happens where cold air moves in like a big wedge underneath warm air. Cold air is always heavier than warm air, and so it's denser, and it's going to tend to slide under the warm air and push the warm air upward. Anytime you have air rising upward, it's going to expand and cool and lose its ability to hold moisture, and this will give you a band of clouds and precipitation along the cold front. On weather maps, if you watch the weather on the news, you can see cold fronts marked by lines of blue teeth that point in the direction the cold air is moving. Along cold fronts, you typically have very intense local thunderstorms and rainstorms. So it might pour rain for a short time, but then quickly, usually within an hour or so, the front will have moved on. So a cold front is where the cold air pushes underneath the warm air, and you have high rainfall and usually intense thunderstorms. Now, the warm front has in common a couple of things with the cold front. One is that the warm air still goes up on top of the cold air, but in this case, the warm air is actually pushing the cold air out of the picture. So the warm air is winning, and that's how you can remember it. It's a warm front. The warm air pushes against the cold air, squeezing it out, like imagine squeezing a watermelon seed between your fingers. It kind of squeezes out, right? And as the air pushes, it also rises up over the cold air. Rising air, again, loses its ability to hold moisture, and you tend to get clouds and rain. Along warm fronts, you typically have more mild, more mellow, more spread out rainstorms rather than really local intense thunderstorms. And if you're looking at the weather on the news, they mark warm fronts on maps with red half moons that point in the direction that the warm air is pushing the cold air. So that's cold fronts and warm fronts, major precipitation belts in many places on the earth.
So as explained, a thunderstorm forms when warm, wet air rises rapidly, super quick. A typical cumulonimbus cloud has ice crystals near its top. Sometimes these ice crystals act as a nuclei to trigger further growth of cloud droplets. This forms hail. Rain or hail produced during a thunderstorm can cool the surrounding air and cause it to sink. Remember? Cold air sinks, warm air rises. This sinking current of cold air is called a downdraft. When a downdraft hits the surface with particularly strong force, it spreads out in a series of windy gusts called squalls. A tornado forms cumulonimbus clouds where strong updrafts create a vortex effect. This map shows where tornadoes frequently occur. A twisting funnel-shaped tornado can move across land at a speed of around 50 kilometers per hour. Intense circular winds in the funnel can reach speeds up to 400 kilometers per hour.
You've got to get further ahead of it.
I know what I'm doing.
Cut across the field, Bill.
I don't have to get ahead of it.
You're going to have to get into the field.
Do you want to drive?
I'm just saying.
Would you like to drive? Be mad later, right now I'm trying not to kill us. Funnel getting thicker. It's moving fast. Coming towards you, Joe.
It's starting to turn.
Where? I can't see it.
You will. Yeah, that wasn't so bad. Let's get it ready.
Why can't we spend a normal day together?
So what's the difference between tornadoes and hurricanes? Well, hurricanes are tropical storms that cover large areas and last 4 days. When winds exceed 118 kilometers per hour, tropical storms develop into hurricanes, which I call their type of tornado.